Let's have a quick look at how to convert complex numbers from Cartesian to polar form. Okay, so what we're going to do is convert this number here. Z is going to equal the square root of 6 minus the square root of 2i. Never hurts to draw a diagram. I think a diagram is a really good idea to get your bearings, if you'll pardon that pun. So we've got the square root of 6 as the real component and square root of 2i as the imaginary component. So we form a little right angle triangle there, and we're very interested in the angle theta. Okay, so let's go through this. We know that our answer, or the argument, is going to be a negative theta. That's the first thing to get sorted in your mind. And generally these problems, the ones we're looking at anyway, are going to involve exact trigonometric ratios. So I've drawn a little right angle triangle here, and you can see that it has sides square root of 6 and the square root of 2. Okay, now I do note that if I divide both sides by the square root of 2, I get a similar triangle. Okay, so the cut factor is kind of negative square root of 2, isn't it? So then I'll get a right angle triangle with side 1 and the square root of 3. Now that brings to mind this famous exact ratio triangle, doesn't it? The equilateral triangle, where you've got a side 1, 2 and square root of 3. Well, once you make a right angle triangle out of it. So therefore, where do we go from there? Well, to begin with, theta here is going to be pi on 6 because tan theta is going to equal 1 over the square root of 3. That's what I want. So we've got theta equaling pi on 6. Now the only thing I've got to bear in mind is my diagram has shown me that the complex number is in the fourth quadrant, so it's going to be negative pi on 6. Okay, from there I've just got to find the radius, and that's easy enough. The radius is simply the modulus of z, and you should be able to follow the working there. So square root of 6 all squared plus the square root of 2 all squared is correct, and therefore I've got the square root of 8, and which simplifies to 2 square root 2. So in conclusion, my Cartesian number is going to be converted to 2 square root of 2 cis negative pi on 6. Here's another example, example 2, you might care to look at, and you should probably be able to follow that by now. Take a look at it, pause it. I'm just going to move it up a bit. I've got my similar triangle there, working out how to find theta. Again, I know it's going to be a negative pi on 3. Remember, our argument must be between negative pi and pi. And we're finding the the value of r in the usual way. It's equal to 1 in this case. And so z is going to equal cis negative pi on 3. And that's the end of this little clip.